This is a problem solving about electric current, a charge, and time. So just to remember that by definition, an electric current is defined as the total number of charge represented the letter Q passing through a section of a wire, for example, in a given time t. The total charge, if we are talking about electric current in general, it is about flow of electrons. And one electron, the charge of one electron is 1.60 10 to the negative 19 coulombs. So if you multiply by the number of n of electrons, so n multiplied by the charge of electrons, that would give us the total charge of Q. So if you divide it by a given time, then that will allow us to figure out the number of current, electric current. So let's solve this problem here, and we will just focus in on the this simple equation. Okay, so I'm gonna read it. CD is connected to a battery that supplies it with a current of 0.22 amperes. Question number one, how many electrons pass through the disk drive in 4.5 seconds? Express your answer in multiple prefixes. So if we have something around the 10 to the 12, then I'm going to use tera, which is T. If it is about 10 to the 15th, I'm going to use the peta, P. If it is 10 to the 18th, then I'm going to use the prefixes exa. So these are just used to simplify the expression of a number instead of using um, instead of not using the standard equation but the scientific notations. Okay, question number two. For what period of time must the current flow if 7.5? This is 7.5 10 to the 18th. So that's to be familiar with these expressions. E18 means 10 to the 18th. And that's the number of electrons are passed through the disk drive. And the number three, what is the current if 10,000 coulombs, that's a charge, pass at a point in half an hour? So, as I stated before, we will just use we only have one equation. So for the first question, how many electrons passes through the disk drive in a time t equals 4 seconds? So if we write the data, we have a time given, 4.5 seconds. So you have the time given, 4.5 seconds. So remember that unit for time is second. And we are asked to express the number of electrons. And since the data gives us that the electric current is 0.22 amps, so I'm going to use that. But you have noticed that we do not have a Q. Q is not given. So, and the question is, we are solving for number of electrons. So as I wrote before, we can also use the equation Q equals N multiplied by the charge of a single electron. So that gives us the total Q. So we combine those two together. We are solving for N. So I equals N times electrons divided by time. And from here, we can deduce that N, which is the number of electrons, equals I multiplied by the time divided by the charge of the electrons. So this is what we're going to use. This equation, we're going to use this equation to solve the problem. I is given, T is given, E is the charge of an electron, and you just apply all of this, then we can get the answer. So after calculations, we replace I with 0.22, T with 4.5, the charge 1.610 to the negative 19, and that will give us 6.2 times 10 to the 18th electrons. And as it says, we have to use the multiple prefix, so the closest to 18 is just the exa. So we just write it, 6.2 exa electrons. 2 exa electrons. That's the first one. So let's move to the second questions. So on the second questions, it is asking for the period of time. So that means we are solving for t. What is t? For what period of time must the current flow if we have a number of electrons here, 7.5, 10 to the 18th electrons have to pass through the disk drive. So remember that from the beginning, we are given the electric current, which is 0.22 amps. So just we do the same calculation. So I will take Q, isolate Q from the given equation here. So Q over I equals T. And since I is the number of electrons, multiply with the charge of electrons, then you can write it this way again. So replacing all of the given data, the number is 7.5, 10 to the 18th. The charge of an electron is 1.6, 10 to negative 16. And from here, we can calculate the time when we divide all of this by 0.22. So after calculations, that will give us a time. So remember again that time is in seconds. So the time would be 5.5 seconds. Also just applying the sig fix, we have two significant figures, 5.5 seconds. And the last question here is about the current. So if we do not use the current given up over here, 0.22, but in case we have 10,000 charge, 10,000 coulombs, and this is passing through a point of the circuit in half an hour. So half an hour is 30 minutes, and we have to convert the 30 minutes into seconds, so multiply by 60, then that will give us 1,800 seconds. So we just do these calculations here, and that will give us 5.6 amperes. So just use this equation here. This is solving anything related to charge, time, and that's charge divided by time is by definition the electric current, and its unit is in amperes.